So we split up 7.3 into two parts also. Today we're just doing solving by cross-multiplying. And remember, we can only cross-multiply when there's an equal sign in between them. So we have to have two fractions with an equal sign. But we do have a couple steps we need to go through first. Step 1, we're going to cross-multiply everything to set up an equation without fractions. Step 2, we're going to solve for that variable that we're trying to get. And then the last thing, step 3, is we need to check for what we call extraneous solutions. So extraneous means extra solutions that actually don't work. So we're going to be looking for if there's a 0 in the denominator of the original problem. So we do need to solve for where those denominators equal 0. So we do have to be concerned about that. All right, so example 1. So we have 3 over 5x equals 2 over x minus 7. So what we're going to do here first, step 1, we want to cross multiply. So we're going to cross multiply 5x times 2. So let's first just write it out. 2 times 5x equals 3 times x minus 7. Okay, so all I did first was I wrote out the multiplication, and then let's actually do it. 2 times 5x gives me 10x equals 3 times x minus 7. I'm going to distribute here. So that gives me 3x minus 7. Oh, I have 21. Oh my gosh. There we go. 3x minus 21. And then step 2, we want to solve for the variable. So I'm going to subtract 3x from both sides. And that gives me 10x minus 3x, 7x, equals negative 21. And then divide both sides by 7. And we get x equals negative 3. Okay, so that's our answer. Now we do need to make sure that we check for what we call extraneous solutions, and even though we are getting one single answer, we need to write down what makes those denominators 0. So we're going to look at my denominators here, 5x and x minus 7. What two numbers would make either of those denominators 0? If x equals 0, we would get no solution there. So x cannot equal 0. And we can set x minus 7 equal to 0. And that would give me x cannot be equal to positive 7 as well. The point of this is that we're going to get to problems where we might have more than one answer. In this case, we only have one answer that will make this whole thing true. When we have denominators that have x squared or x cubes in them, and then we finally solve for x, we might possibly get 3 or 4 different answers. And some of those answers might not work for the denominator. So we always want to check just in case any of the answers that we get would make the denominator 0. So that's why we do it. So we're pretty much just really quickly checking domain here. Okay? So let's try example 2. Okay, so example 2, I'm going to do the exact same thing. First I'm going to cross multiply here. So I would get 9 times x plus 1 equals 3 times 4x plus 5. We distribute on both of those, and that gives me 9x plus 9 equals 12x plus 15. Okay, so we want to solve for x here. Since 9x is smaller than 12x, I'm going to subtract 9x from both sides. And that's going to give me 9 equals 3x plus 15. And then I want to subtract 15 from both sides. And that's going to give me negative 6 equals 3x. Divide both sides by 3. And x equals negative 2. Okay, now let's check those denominators to make sure that negative 2 actually does work here. So I'm going to set x plus 1 equal to 0. And that gives me x equals negative 1. So x cannot equal negative 1. And then let's also set 4x plus 5 equal to 0. Okay, so I subtract 5 from both sides, so I get 4x equals negative 5. Divide both sides by 4. X equals negative 5 over 4. So x can also not equal negative 5 over 4. So our answer is good here. Okay, so example 3, we have 1 over 2x plus 5 equals x over 11x plus 8. So I'm going to do the same thing. I'm going to cross multiply here. That gives me x times 2x plus 5 equal to 1 times 11x plus 8. Okay, so distributing in, I get 2x squared plus 5x equals 11x plus 8. And since in this problem I have a 2x squared here, I'm actually going to get everything over to the other side so that we can solve by factoring, since there is that x squared. So let's subtract 11x and 8 from both sides. So that's going to give me 2x squared minus 6x minus 8 equals 0. And I want to solve this by factoring. The first thing I notice in here is that I have a GCF of 2, so I'm going to take that out. And that leaves me with 2x squared minus 3x minus 4 equals 0. And so then we want to factor this thing. So we can use diamond on this now. So this is going to be 2 times x minus 4 times x plus 1 equals 0. And then how do I solve for x here? We set every single one equal to 0. So I have 2 equals 0, x minus 4 equals 0, and x plus 1 equals 0. Can 2 ever equal 0? No, so we don't even have to do that one. Right here I add 4 to both sides, and I get x equals 4. And on the third one I subtract 1 from each side, and I get x equals negative 1. So my answer is going to be x equals 4, negative 1. So let's double check that by looking for my extraneous solutions. So I'm going to set each one of those denominators equal to 0 as well. So I would have 2x plus 5 equals 0, and 11x plus 8 equals 0. Subtract 5 from both sides. That gives me 2x equals negative 5. Divide by 2, x equals negative 5 over 2. So we have x cannot equal negative 5 over 2. And then subtract 8 from both sides. 11x equals negative 8. Divide by 11, x equals negative 8 over 11. So x can also not equal negative 8 over 11. So our answer's good? Yeah, our answers are good.
What happens if you come out with an extraneous solution?
Okay, so this is going to be an example of where one of our extraneous solutions is going to end up being one of the answers that we get. So we have here 9 over x squared minus 6x plus 9 equals 3x over x squared minus 3. So first, before we do anything, let's factor both of these guys just to kind of see if we can maybe simplify it a little bit, and it might make our multiplication a little bit easier. How does x squared minus 6x plus 9 factor out? X minus 3 and x minus 3. What about x squared minus 3x? X times x minus 3. Okay. Now we're just doing this right here to check some things. We can't really cancel anything out because that would get rid of one of our answers, which might end up being an extraneous solution. So let's do our cross multiplying here. The x and the 3x right here, we don't want to because it might end up being an extraneous, it might end up canceling out one of our answers. Yeah, so we want to just do our cross multiplication. So we would get 3x times, this would be x squared minus 6x plus 9 equals 9 times x squared minus 3x. Okay. Yeah, so I don't really know why I did that. It was, we don't have to. Habit, I guess. Okay. So we're going to use distributive property here. So that is going to give me 3x to the third minus 18x squared.
Wait. What was the purpose of factoring it out?
I just said habit, you don't need to. Yeah, don't do it. Plus, sorry, 27x equals 9x squared minus 27x. Okay, so we have cubes and squares here. So what we want to do is we actually want to get that whole thing equal to 0. So we're going to move everything from the right-hand side over to the left. So I'm going to subtract 9x squared and add 27x. Okay. So that is going to give me 3x squared minus 3x cubed minus 27x squared, thank you, plus 54x. Negative 18x squared minus 9x squared. 54.
What does that say, plus?
Plus 54x squared. So what we want to do here is we want to factor this. There is a GCF in here. Do you guys know what it is? 3x. So let's factor out the 3x. That's going to leave me with x squared minus 9x plus 18 equals 0. And then we can factor this guy using diamond. So we would get 3x times two numbers that multiply to 18 and add up to negative 9. X minus 6, x minus 3 equal to 0. And then we set each one of these equal to 0. So that would be 3x equals 0, x minus 6 equals 0, x minus 3 equals 0. Divide by 3, that gives me x equals 0. Add 6, x equals 6. And add 3, x equals 3. Okay. Now let's check for our extraneous solutions here. Now the reason why it is helpful for us to have factored it is now we can factor this for when we set them all equal to 0. Okay, so we would have x minus 3 squared equals 0. Square root x minus 3 equals 0. So x equals 3. So we have x cannot equal 3. And if I have x times x minus 3 equal to 0, I would get x equals 0 and x equals 3, right? So x can also not equal 0. Okay. Now those are two of our answers that we got when we solved the problem. So all we do is we don't include those. So we only have one answer for this problem, x equals